Hello all, welcome back. So this will be the CFD domain for this problem. We'll have to create a cylindrical domain. Here the water will be entering at 10 liter per minute at 15 degrees Celsius and it will be leaving the exit at the pressure of 1 atmosphere. We can assume this value. Please note that in the problem they have given the exit temperature and asked what will be the heat flux. But in our case, we will be giving the heat flux and we will be finding out what will be the exit temperature, because we cannot specify the exit temperature in CFD and evaluate the net heat flux. It will be an iterative process. So we will specify the Q value and find out the exit temperature. Therefore, the output will be exit mean temperature, that is TE, and exit max temperature, that is TS. So TS will be present at the casing and TE will be the mean temperature at the exit. Okay. Now let us open Ansys workbench. Open Ansys workbench and drag and drop fluid flow CFX. Right click geometry and click new design model geometry. Choose XY plane and go to sketching. Right click and choose look at. You can change the units to millimeter. The domain diameter is 3 cm and the length is 5 meter. Okay. We shall draw a circle of 3 cm diameter. We shall specify the diameter. Go to dimensions, diameter. The diameter is 3 cm or 30 mm. Okay. Next we can come back to modeling. We can rotate the sketch. Click extrude. Select the sketch. Apply. And the length is 5 meter. Therefore, it will be 5000 mm. Click generate. The model has been generated. It is a bit long, but anyway we will create the mesh and do the analysis. Now you can close design modeler and go to meshing. Right click mesh and click edit. Ansys meshing is open and the model is imported here. First let us create the named regions. We shall select this face, select face filter, right click, create named selection, inlet. Similarly, select the other end, make sure to choose the face filter, right click here, create named selection, outlet. Next we shall specify the cylindrical face, right click, create named selection, let it be wall. Now the names have been specified for the 3 boundaries. Next let us specify the element size. Go to mesh. We can choose the element size here. Make sure that here we can specify more number of elements on the face, and along the length we have to specify the elements judiciously, because the length is longer compared to the diameter. So we have to specify the elements in the face separately and the distribution of elements along the length separately. Okay. Let us choose the element size as 2 mm here. We can see the crosshair circle represents the approximate element size here. So if you see in this face, this is how the element size will be looking. So 2 mm should be sufficient. Okay. Next, let us specify the boundary layer elements, for which you have to go to inflation. Here you have to specify the option use automatic inflation. Choose this drop down menu and choose all the faces in the chosen named selection. Now you can choose the wall region in the named selection. This is important. If you miss, then we will not be able to select the inflation layers properly. Next, go to the inflation option. In the drop down, you choose first layer thickness. Okay. Here we have to specify the first layer height. We can specify the first layer height based on the turbulence model we are going to choose and the Y plus we are going to consider. Okay. For this case, let us choose K omega SST turbulence model, for which Y plus should be less than 5. In this case, we shall take Y plus as 3, and for this Y plus and flow conditions, the first layer height comes to 0.1 mm. I will show the calculation quickly. We can enter the free stream flow conditions and other fluid properties in this Y plus calculator and specify the desired Y plus. For Y plus of 3, we get the estimated wall distance is 0.12 millimeter. So in this case, we shall specify 0.1 millimeter and solve the case. Now let us go back to Ansys machine. We shall specify the first layer height as 0.1 mm and the number of layers, let it be 7 layers, and the growth rate, let it be 1.2. Next, we shall specify the number of elements or the element size along the length direction, for which you have to use a separate method. Right click mesh, insert method. Here you can select the geometry first, apply, select the method as multi-zone. In this option, you can specify the number of elements along the length. Here we can see the sweep size behavior. It will automatically select the source and target regions. It means it will try to sweep the mesh from one face to the other face. Here we shall specify the sweep element size. We can choose approximately some 100 mm or 50 mm because the overall length is 5 meter and approximately the element will be distributed here. So this crosshair shows the element size along the length of the body. So this may be a bit high. We can take around 50 mm here. This should be fine. Okay. Now we have specified the boundary layer elements, element size in this face, and also the element size along the length. Now right click mesh and click generate. Mesh has been generated. You can see how the elements are distributed along the length, and we can see the boundary layer elements as well as elements in the face region. Okay. We can see the mesh statistics in this option. Here it shows the number of elements and nodes for the geometry. So the number of elements are approximately 50,000. We can also check the element quality in this option. Expand this quality, and here you can choose the mesh metric, whichever you want to see. You can choose element quality, or you can choose aspect ratio and see. Here we can see, and some elements are having high aspect ratio, especially near the boundary layer. So aspect ratio refers to the ratio of length to width of a cell. Similarly, you can plot other mesh parameters like skewness, orthogonal quality, and other details. Okay. For this case, this mesh is sufficient. We shall go to CFX preprocessor. We can close meshing now. Right click mesh and click update. Okay. Meshing is complete now. We shall specify the boundary condition and set up the case in next lecture. Thank you.